sort of showed you the graphs. What was all that about? I was asking you to consider that we are doing equivalence transformations. Okay? What was the big thing about equivalence transformations I'm saying? Cameron?
It keeps the answer.
What was it called? Not the answer, the...
Factorizing.
No. Yeah?
Solution.
The solution. Okay? So, for instance, the first one, if we have to solve 2x plus 3 is equal to x subtract 7, right? First of all, what are we looking for when we're asked to solve that? Don't say x. Yeah?
It would be how to like transform the equation to.
No, like what? If I ask you to solve it, what's the end point? And I don't
so
want
it-
just the answer
at
x.
least
So
what
it is
I-
x, but what is x?
The point where the two lines intersect.
Ah, but that's what we would find visually, but it actually has that visual point, you're right, where two lines cross. But what does it mean in terms of our equation?
The y.
No, definitely not. But what is the solution?
When x is the same on both sides.
See, I would say we're not finding when x is the same on both sides, although that is what it looks like. How many x's are we trying to find?
3. 1.
1. Yeah? And what we're saying is we need a value of x, right? One value of x that does what? Cameron?
The equation equals what x would equal.
Say it again.
The x equals what the equation represents.
That doesn't make sense to me.
Right. Pretty much the answer to the equation is.
So what does answering the equation mean? Steph?
Finding the x value that makes the two sides equal.
Yes. Right? We are finding one, potentially more than one, if it's different equations, where I can put the same x value into both sides, and we have that equality, yeah? Right? So I could put an x value in which makes them different, yeah? But we're looking for the x value that makes this and this have the same value. Now, the reason why I want to go through that is because I can rewrite it as y equals 2x plus 3 and y equals x minus 7. And then we have, like Steph said, we've got two straight lines and we're looking for where they cross. Why is that the solution? Steph?
Because the point where they cross would be the point where x is the same for both of them.
Not just x, but
The y.
the y is the same for both lines. Because a line is what? See whether you remember. Right? So dots, but I would actually say
Points.
points.
It's an
An infinite number of points, yeah? So it's interesting because I'm talking about this with M5s as well at the moment. If you think of it as an infinite number of points, then that point there is the point that is made up of both lines, yeah? Where the x and the y value are the same. Now this is important because if I consider this, I can say that 2x plus 3 is equal to x minus 7. But I can also say, and you might say, well, why bother? Because it's obvious. But it's nice to understand that also that y equals y. Does that make sense?
Does that mean x equals x?
Yes, but more importantly, 2x plus 3 is equal to x minus 7. Now, the reason why is because I want to show you that writing it this way or writing it this way and solving it, you get the same thing. All right? So when we talk about our equivalence transformation, do you remember yesterday we looked at the two lines and we showed we can move those lines around? But what happened was, remember I said there was a a line going through there which was the solution, x equals something. And if I change these two equations but change them in the same way, they move around, but where it crosses, always crosses on the line, yeah? Even if the lines are two different. So that's what we mean by the equivalence transformations. Right, so that's quite an important one. So let's just have a look. So 2x plus 3 is equal to x minus 7. How do we solve it? What's the process? Jack?
We want to isolate x.
Okay, you want to isolate x. So first step, what would you do?
Add 7 to both sides.
So add 7 to both sides. Right. What's the purpose of adding 7 to both sides?
Put the x on the right on its own.
Okay. Now, what I want to say is, this is I'm focusing on the equivalence transformations. This is equation number 1. Let's say equation number 2 is now, if I add 7 to both sides, I have x minus 7 add 7, and I have 2x plus 3 add 7.
It would
Right.
be 2x plus 10 equals x.
So 2x plus 10 equals x. Now, I guess the basic understanding is that this is not the same as this, is it? But what do they share?
Same solution.
The same solution. So that's where the equivalence transformation comes in. All right. So I've now got 2 sets of equations with the same solution. So let's come up with a third set, which limits it even more. What can I do at this stage?
Divide the x by 2.
Divide by 2. Hang on, before you correct, let's have a look at this. So if we divide both sides by 2, let's do 2x plus 10, divide that by 2, and let's do x divided by 2. Right.
Well, that doesn't change it.
Well, let's see whether it does what you think it's going to do. All right. So let me, I think I've still got Desmos. Yeah, got Desmos. All right. So what did I have on one side, guys? Y equals 2x plus 10. All of that is divided by 2. And then I had, let's get rid of that one. What's the other side? Y equals x divided by 2. Okay, so we think that's the solution. All right, what's the solution going to be that we think? Minus 10. Now, what I'm after is then, why did you decide to divide by 2, Liam?
Because you wanted to get rid of the 2 that's closest to the x.
Okay, so what do you think this simplifies to?
X plus 5 equals x over 2.
Okay. All right, so let's just check using our graph. Do we get, so if I then say this one would actually be, what did you say? X plus 5. So that's right, yeah? So what he said, by doing the divide by 2, is it an equivalence transformation? All right? Did he do anything wrong? No, I thought he was going to do something wrong, but he didn't do something wrong. So why did Stefan go immediately up?
Because that doesn't tell you the value of x.
Okay. Has it taken us any closer to where I want to be? No. It's not wrong. So quite often when we solve equations, now, this is absolutely fine, but it doesn't get us where. Does anyone know what I thought Liam was going to say when we divide both sides by 2?
I would say x plus 10.
Yeah. So x plus 10 is equal to
X over 2.
x over 2.
Which is
All right.
right.
Which would have been wrong, right?
Yeah.
So you see, so that's good. So, but when we've got x plus 5 is x over 2, the problem isn't that we've done anything wrong, it's just that it's
We
not.
haven't gone anywhere.
Switch it off.
Where's the switch? Where's the kill switch?
Where's the switch? Hey, is there somewhere around here? I'm just gonna have my
Just
little-
can't get out. Some teacher's gonna come in and be like,
Yeah.
why is this off?
There you
Poor printer. Just got killed.
Alright, so we're alright. We've done a correct thing, but
We're not closer.
we're no closer. So maybe that decision wasn't one we wanted to do. So
Yeah.
let's not do that one then. Let's do something else. So what can we do instead, Steph? Subtract x from both sides. So now we have a new one. So 4 would be 2x subtract x plus 10 equals x subtract x, which is,
So x plus 10.
so
equals
x plus 10 equals
0.
0.
Meaning x is negative 10, right?
Right. Now, why would a lot of people get a bit unhappy at that stage and flinch a little bit? That,
This is 0.
there's a 0. Right? Lots of people look at that and go, oh, what happens now? Well, what I see a lot of people do is when they get to 0, they actually get rid of the equal sign and just get left with x plus 10 and then don't know what to do. Alright? I see it quite often actually. We have to write what it is equal. It is equal to 0. Okay? It has a value. The equal sign is that you can't just get rid of the equal sign. Just like you can't chuck in an equal sign if you fancy having one. Alright? And then finally we have x plus 10. If we subtract the 10 and we've then got equals 0 subtract 10, that gives us our
equals
fifth
negative
one. X is equal to negative 10. Alright? Which is actually, is this a solution or an equation?
Solution. Or it's both.
Both, good. Both, isn't it?
Because
X equals negative 10 is new. What does x equal negative 10 look like on a graph step? Yeah, it's that line here, isn't it?
oh, so I was right.
So I've just unplugged it. It was really annoying. It was beeping and everything, so we couldn't figure out. So I've unplugged it for now.
Yeah, because you haven't defined the y-axis, so it should be a line.
Yeah, so the equation is if that point there would also go through x equals negative 10, okay? And that would be, it's an equation of a line, but it's also the solution to where these two cross. Alright? Got it?
Yeah.
So it's, I know you might be thinking, oh, but it's easy, that's just what we've been doing anyway, but I want you to keep in mind the equivalence transformations. Alright? So, bear in mind we've got these ones that others to do. Are there any in there that you think we'd like to go through together, or do you think you can get on with them?
I was wondering if we could do D.
D? Anyone else, or do you want to? Should we have a look at D together, or
What
one
we're going to
more?
say about this is the first part, which is 1 minus 3.
Should we have a look? Can you read it out for me there?
So D is 1 minus 3.
Okay. Lots of different parts to this. Okay, so what can we do first?
Get
Keep
rid
it
of
down. Jack? Expand the brackets. Why is that your choice?
Because you cannot really do much with the equation of subtracting on both sides until we have.
Okay, so the issue is these extra little terms here, isn't it? The adding on afterwards. We want to be able to combine them into the other stuff, but we can't do that until we expanded the brackets. So if I expand this side, what do I end up with? Anaya. Sure? So I could write 1 minus 3x plus 6.
Wait, Mr. Fox?
It's
Hang on.
I just had a question. Is this
Okay,
one
hang
use
on.
bed mass?
out what we've just said there? Cameron?
It's negative 3x plus negative 6.
Okay, so we've actually got 1 subtract, this is what I think, 1 subtract all of this, yeah? So what you could do, if you wanted to, is keep this in brackets, alright? That's alright, but then we have to do 1 subtract 3x is 1 subtract 3x, but 1 subtract 6 is, but we can do our negative 6 if we want, and we end up with negative 5 subtract 3x. Yeah? But be very careful with negatives. Alright? Very careful when you see a subtraction. Always double check what you're doing. Alright? So we've got that on that side. So I've not done any equivalent. This is just another way of writing the same thing, right? This one and this one are exactly the same. It's not an equivalent. There's no transformation yet. It's just another way of writing it. What do we do on this side? So we've got
1/2.
a half of 2x is
1x.
1x. A half of negative 8 is, and then we add 3. So we end up with
X minus 4 plus 3, or x minus 1.
Okay. All right. So that is still the first equation. Where do I go from here then? Cameron at the back. Let's just see. What would you do to make my second one? Add 1 to both sides. Okay. So we can do minus 5. I'm going to add the 1 to that term. And I've still got subtract 3x. And then I've got x subtract 1, add 1. And I end up with?
Negative 4 minus 3x equals x.
Okay.
And then would it be...
Should we? Can I get everyone involved? Thank you for your offers. But anyone else? Owen. I think what he was going to say is subtract the x, which is fine, but it doesn't take us the direction we want. We can instead what? Add 4. Again, I could add 4, but probably the best thing would be to do subtract 3x. Let's add the 3x instead. And this side I've got x add 3x. I end up with negative 4 equals 4x. So a tip is always try and keep a positive x if you can. Aiden?
And then we divide by 4.
Yeah, if 4x is our negative 4, right, we're going to divide by 4 on both sides. Gives me 1x is the same as
Negative 1.
negative 1.
Mr. Fox?
Yes.
Back when we had negative 4 minus 3x equals x, why didn't we just subtract the x's so it's negative 4 minus 3?
Just have a think, hang on, let him think. If I subtract the x instead, what would I have ended up with? Negative 4 minus 3 equals 0.
Yeah, and then
That makes negative 7 equals 0.
wait, wouldn't it be instead of negative 4? Wait, instead of by subtracting x, isn't it 3 x's? So wouldn't it be negative 4 minus 2x?
That's better than what you initially said, which was the getting rid of the x. What's negative 3x's? Subtract another x. Negative 4. So we could have had at this point minus 4 minus 4x equals 0. And I think that was what Owen was going to do first off, wasn't it? I think. Which is not a problem. But I would have then had to add the 4x. And then I would have added the 4x both sides and ended up with
Negative
where I
4.
was anyway.
So it wouldn't have mattered.
It doesn't matter, no. I guess that's the important thing to say. It doesn't matter. What we're trying to just do is be efficient.
Yeah.
Get there as soon as we can. Okay, unless you've got any more questions, have a go at the rest. What I would like you to do, though, guys, is using your laptops, if you're allowed, 3 people aren't, I would like you to confirm, please, using Desmos, that your 2 equations can be written separately, draw the graph, find the solution that way, and confirm that your answer matches that. Alright? And what I would also like you to do is confirm that at least one of your steps en route changes the 2 lines, but maintains the solution. Do you remember I did yesterday? The reason why, again, you might choose like, oh, I don't need to do that, but I'm trying to get something ingrained into your brain that links in with this topic. All right, and that's matching the different functions and the different lines with the solution. All right?